This is my first video. What the fuck do I say? Hey there, my favorite LeetCode enthusiasts, my favorite LeetCode warriors, my favorite LeetCode brethren. It's your boy Michael here, hopefully your new favorite teacher, and welcome to my channel. So I've decided to start off this channel specifically with this playlist because I know there's a lot of you guys, especially nowadays with the thing that is going on right now in the world that for whatever stupid reason YouTube isn't allowing me to say that for good reason are staying up till 7 in the fucking morning with 5 Chrome tabs open on LeetCode, 7 on LinkedIn, another 6 on Glassdoor or whatever, and 600 on Stack Overflow. If you have never solved a coding problem and you don't know really how they go, basically they give you a problem and then you have to come up with a series of steps as to how to solve that problem with any input rather than with a specific input and like a specific scenario like you do with math or chemistry problems. Technical interviewers or websites like LeetCode or HackerRank will then get that code and they'll test it usually against 20 to 400 inputs with the purpose of testing your code at best and your patience at worst. With that being said, let's start off this playlist with the twoSum problem. Alright, so this first problem is pretty simple. Given an array of integers nums and an integer target, return the indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answers in any order. Okay, so the first thing that we have to do with LeetCode problems is understand what they're asking us. So here we have an array of numbers, a, b, c, all the way up until n. Let's say we're given a target of x, and let's say we're given this array as well. Does there exist two numbers in this array such that when we add them up, we get the target value x? And if these two numbers do exist, what are their positions? So essentially our code has to return the positions of the two numbers in the array such that when you add them up, they equal to x. So how do we do this, you may be asking yourself right now. Well, I'm glad you asked, my friend. Let's get this show on the road. So before I go on, I feel like I must inform you guys, especially the guys who have never done a single LeetCode problem, that unlike other disciplines, one single LeetCode problem could have multiple solutions. However, not every single solution is created equal because there are some algorithms which are simply more efficient in terms of how fast they run and how much computer memory they use. Some solutions look like they run really fast and that they're really efficient because, you know, they're given small inputs like a small array or something like that, or a small matrix. But once you start giving them larger inputs like larger numbers, larger arrays, larger matrices, they can grow to become extremely sluggish. You'll see this in a lot of coding problems. As a matter of fact, websites like LeetCode usually have a time limit that each algorithm has to run. So if the algorithm exceeds that limit, then automatically that question is considered to be wrong. You'll get a time limit exceeded message if you try to run it. So I'll be ranking these solutions based on their efficiency using this meter on top over here. The solutions that are to the left of this meter are those solutions written by coding noobs with an arguably better sex life than 90% of all Stack Overflow users. The solutions that are to the right of the array are those solutions that are only written by those super LeetCode enthusiasts, those LeetCode connoisseurs, those wannabe Bill Gates, Mark Zuckerberg type of people. So please don't get discouraged if you don't understand a LeetCode problem, a LeetCode solution, or anything having to do with LeetCode, and please drop a comment if you need help. Alright, so back to the problem. So we gotta find two numbers in this array such that when we add them up, we get x, which is our target value and our input value. One solution is to simply check all the possible combinations of every number that we have in this array. And doing that is actually pretty simple. We just need two nested for loops. The outermost for loop is going to contain the first number for every combination that we're going to check. And the innermost for loop is going to contain the second number of every combination that we check. And we're going to name these pointers P1 and P2 respectively. Okay, so the first for loop is going to traverse the array with P1, and for every number that we come across with P1, with pointer P1, we're going to start a new for loop with pointer p2 that's going to start right in front of p1, and it's going to iterate through all the numbers in the array. Of course, this does not include the number that p1 is pointing to, because the LeetCode problem says that we cannot use the same value twice, and also we can't check the numbers that come before p1 because, you know, we'd be checking duplicate values and that's just redundant. So p2 is going to start off right in front of p1, and we're going to get the numbers that are in p1 and the numbers that are in p2. We're going to add them up and we're going to check to see if they equal to x. And if they do equal to x, then we're just going to return a new array which contains p1 and p2. And if we don't, we're just going to move p2 over to the next value and then check those two numbers. And we're gonna keep doing that: traverse, check, traverse, check, traverse and check, traverse and check, until we get to the last value here. And once we get to the last value, that'll be the end of the second for loop. So now the first for loop is going to go to its next value. So we move over p1, and then we reset p2 over to be in front of p1, and then we do the same thing: traverse, check, traverse, check, traverse, check, traverse, check. And we're just going to keep doing that all the way up until p1 gets to the second to last value, because after that, you know, p2 is right next to it, and p1 and p2 cannot be pointed to the same number, because, again, like I said before, can't use the same element twice. So once we get to that point, and once the two for loops are done executing, we still can't find numbers that are equal to x. When we add them up, then we'll just return an empty array, and that'll be the end of it. Alright guys, so let's get this show on the road. We're gonna start out with our first for loop. We're gonna say for integer p1 is equal to 0, p1 is less than nums.length minus 1, and we're gonna say p1 plus plus. Then we're gonna do here for integer p2 is equal to 0. Actually, no, it's equal to p1 plus 1, because it has to be next to p1. And we're going to say p2 is less than nums.length. Remember, with pointer 1, we're only going up to the second to last element, because if we end up with having an array, if p1 is at the end of the array, then that means that p2 would be out of bounds of the array, so we would get an error as a result. So we're saying up until nums.length minus 1. With the second one, p2 can just go all the way to the end of the array. That doesn't matter. And then we're gonna say p2 plus plus. Oh, is that p? It's p2. There we go. Now we're gonna check whether or not the numbers that p1 and p2 are pointing at are equal to x when you add them up. So we're gonna say if nums at p1 plus nums at p2 is equal to target, and then we're going to say if it's equal to target, then we return a new integer array. Inside the curly braces here we put p1 and p2, and then yeah, that's it. If we go through these two for loops and we don't find those two numbers that we want, then we just return an empty array. So we're gonna say return new int empty curly braces, and then we submit this code. Let's see how we do. Now this code did run pretty fast. As you can see, you have a 0 millisecond runtime, 100% faster than all Java submissions, uses 39 megabytes of memory, which is not too much, I would say. But here's the thing. It scales horribly. It does well with small inputs, but once you start using larger ones, the amount of steps that it takes to complete skyrockets pretty much exponentially. And this is because, as you can see, with the first for loop, we're iterating through the array, through all the elements in the array, nearly all of them. But for every number that we come across, we have another for loop that's iterating through almost the entire array again. So for example, if we have an array of 3 elements, for every number that we come across, we're iterating another 3 or 2 times, you know, around 3 times. So this means that, we have an array that has only 5 elements. The amount of elements that we are actually visiting, the amount of combinations that we're actually considering is about 5 squared, or 25, right? But what if instead of having 5 elements, we have a much more realistic amount, like 10,000 per se? What's 10,000 squared? 10,000 squared is like 100 million. That's a lot. That is a lot of steps. So because of that, I'm putting this solution in the noob category. So with that being said, however, is there a more efficient solution? And I would say yes, there is definitely a much better solution to this problem. So this is where the concept of maps come into play. Maps are unordered sets of key value pairs. So that means that we can't iterate through them in the same way that we can an array. However, most functions fortunately have methods to check whether or not a specific value exists given the key, and it allows us to get that value using the key. In Java, these methods are called ContainsKey and get, respectively. How could we use this for this problem? Well, we could use one for loop, and that for loop will iterate through the entire array, and every number that we get to come across, we're going to pretend that number is a. Then we're going to use that value a to calculate the complement of x, and then we're going to check whether or not the complement of x exists within the map. And if it does, then that means that we found our match, so we just get the associated value, and we get the pointer that is pointing to a, and just return those two values in an array. And if we can't find those two values, we'll just return an empty array like last time. So let me show you an example. Alright, so let me just do an example real quick here. Let's say, for example, we have this array, and this is our target. So the first for loop, the first thing we would do is fill up a map with all these values, and this map will have the values of the array on the right hand side of all of the on the left hand side of all the key value pairs, so they'll be the keys, and on the right side we'll have the positions over here. So after we fill up this map with the values in the array, we'll use another for loop to declare a pointer, and we're going to make this pointer traverse to the entire array. And this pointer here, for example, we'll move it over to the first element. So we're going to get our first element is 1. So then we calculate what the complement of x is, the complement of the target. The complement will be, in this case, 8 minus 1, which will be equal to 7. And then we check to see whether 7 exists in the map. And lo and behold, here it is. So, since it exists in the map, we'll just simply return an array which contains p1 and the associated value of 7, which is 5. And that will be all. If 7 did not exist in the map, we will just move p1 over to the next value, and then we'll calculate the complement and then check to see if that exists. And then we'll do that over and over again until we either find a complement that exists in the map, or until we just run out of elements to check in the array, in which case we'll just return an empty array. So here I have copied and pasted the code here just for the sake of brevity, but let me show you what it does real quick. So here I have HashMap. I'm just declaring it over here. Then I'm filling up the HashMap in this first for loop with the values of the array and their associated positions. In the second for loop, here is where we're checking to see whether the complement exists. So here we have the pointer p1, and then target minus nums at p1 is the complement. And then if this if statement, we're checking for two things. Namely, we're checking to see whether or not the complement exists within the HashMap. This is what the ContainsKey function does, as I stated before. And if it does exist, you want to make sure that the associated position does not equal to p1, because as the problem has already stated before, you can't use the same element twice. So if these two statements are true, we'll simply return a new array with p1 and the associated position of the complement of x. In the end, if nothing happens, we'll just return a brand new array, brand new empty array. Let's see how this code runs. So here we have a 4 millisecond runtime, faster than 50% of all Java Online submissions, with a 41.7% megabyte memory usage. So I know this might seem a lot slower than our previous solution, but we're using 2 non-nested for loops, and as a result of that, the amount of elements that we're actually visiting is only 2 times the element, the size of our array. So if we had an array of 10,000 elements, we'd only be visiting 20,000 elements, more or less, versus 100 million like we had in our noob solution. So as a result of that, I'm going to put this solution in the boss category. Alright guys, this is the end of the video. Thank you so much for sticking with me through my first video. Please like, comment, subscribe, and hit the little bell icon to be notified when we drop a new video. And drop a comment if you have a request for me to do a specific LeetCode problem. This is your boy, the Big M, signing out.